Hello everyone, welcome to today's video on solving one-step multiplication and division equations. We'll start with key vocabulary. So first, what is an equation? I know you've seen many before. Equations are mathematical statements which say two algebraic expressions are equal, and they include equal signs. Then we have a solution to an equation. This is a really important term. So a solution to an equation is a value for the variable that makes the equation a true statement. So we know that a variable is a symbol, normally a letter, that represents a possible number or numbers that we can substitute in for that variable. So a solution to an equation, we're going to be solving equations, meaning trying to find the solution. And that is the value of that variable, so like the number for that variable that's going to make the equation true, meaning that what's on the left and right hand side of the equation are equal to each other. And lastly, we have inverse operations, which are super important to the idea of solving equations. Inverse operations are operations that undo each other. Okay, that's a word I'm going to be using a ton in this video and for the rest of the year. You will hear me say it all the time. Solving equations is all about undoing or inverting what's currently happening to the variable. So multiplication and division for our video today are operations that undo each other, and they are inverse operations. Why do they undo each other? Well, let's say that I start with the number 5, and then I decide to multiply 5 times 2. I'll get 10. Okay, and then I want to divide what I got, 10 divided by 2. And 10 divided by 2 is, of course, 5. So what I did is I started with 5, I multiplied by 2, and then I did the inverse, or I undid multiplying by 2 by dividing by 2. And I ended up with what I started. First I did something, and then I undid it. So I multiplied, and then I divided both by 2. So those undid each other. So solving equations is going to be using that idea of how do we undo what's currently happening to the variable. And that's going to help us find our solution. So that leads us to the two questions we will ask ourselves when solving equations. And I will say these to you constantly throughout the year. So question number 1, what is currently happening to the variable in my equation? And then question number 2, how can we undo or invert that? What is currently happening to the variable? Okay, and we'll of course see that play out in examples today. And then just two things to keep in mind. When you do something to one side of the equation, you must do it to the other side of the equation. That is in order to keep the equation true or balanced. So if you have something, these two things are equal, and then I add 5 over here, well, that's going to get bigger, but now all of a sudden I don't have a true equation. They're not equal to each other. But what I can do is if I add 5 over here, I can add 5 over here, and now again my equation is true, or the two sides are equal to each other. So that's going to be essential. And then we're always going to be able to check that our solution is correct, and that's a great thing to do, so I'll show you how to do that as well. All right, so let's look at our first example and our first try it, which is, for example, solve negative 3x equals 15. So I rewrote my equation. That's always a good first step. And then I'm going to ask myself the two questions. So question number 1, what is currently happening to the variable in my equation? So I see negative 3x equals 15. When I have a number, the term is a coefficient here, next to a variable, there's a hidden operation going on. That means negative 3 times x. And we just don't write it that way. It's just convention. It's easier. You'll see it. You'll have to get used to it. Okay, so negative 3x means negative 3 times x equals 15. So what is currently happening to my variable? Well, it's currently being multiplied, right? It's being multiplied by negative 3. So how can I undo or invert that? How do I undo multiplying by negative 3? Yeah, well, let's go back to our inverse operations if we need to. What's the inverse operation of multiplication? Division. So I'm going to undo multiplying by negative 3 by dividing by negative 3. So I'm going to do that to both sides of my equation in order to keep the equation balanced or true. Okay, so on my left-hand side, I'm going to divide by negative 3. On my right-hand side, I'm going to divide by negative 3. On my left-hand side, I have negative 3 divided by negative 3, and then times x. Negative 3 divided by negative 3, I'm just going to cross that out, that cancels away. But why does it cancel away? Well, I have negative 3 divided by negative 3, and that's some number. Any number divided by itself is equal to 1, right? Any number divided by itself is equal to 1. So then I get 1 times x. 1 times anything, including a variable, is just itself. So 1 times x is x. So that's why I can just write x on the left-hand side, because I've canceled away or undid the multiplying by 3, right? The other way to think about it is x is currently being multiplied by negative 3. Now I'm dividing by negative 3, so those undo each other, and we just get what we started with, which is x. Okay, and then on the right-hand side, I just need to figure out what is 15 divided by negative 3. 15 divided by 3 is 5, and we have one positive and one negative here. Okay, so x equals negative 5 is the solution to this equation. I can check my work by rewriting the equation. Negative 3x equals 15. And making sure that I get a true equation, meaning, again, what's on the left-hand side of the equation and the right-hand side is equal. When I multiply negative 3 times the value of x, which we know here is negative 5, I should get 15. So is negative 3 times negative 5 equal to positive 15? Thus I get 15 equals 15, so I know I'm correct. I have checked my solution. Okay, awesome. Now I want you to try number 1. So solve 5x equals negative 40. Again, you want to ask yourself these two questions. What's currently happening to the variable in my equation? And then how can I undo that? And whatever I need to do to both sides of the equation in order to keep my equation true and balanced. Okay, so go ahead and do that. Awesome work. So you should have gotten x equals negative 8. 5 times negative 8 is negative 40. So I get negative 40 equals negative 40. That is the correct solution. I have a value of x that makes the equation true. All right, awesome. Okay, so that's a situation where what was happening in our equation was our variable was getting multiplied by some number. Now we'll check out what happens when our variable is getting divided by some number. Okay, so if I look at example 2, I have negative 5 equals x divided by 6, or x in the numerator, 6 in the denominator. Remember, this is a really important rule that will also come up a ton this year, is that a fraction bar means division. So this is just one way of representing x divided by 6. Did I just answer my first question? I think I did. What is currently happening to the variable in my equation? It's getting divided by 6. And I know it's currently being divided by 6. So now I'm going to ask myself, how can we undo or invert dividing by 6? You multiply by 6 because division and multiplication are inverse operations that undo each other. So we need to multiply both sides of the equation by 6. I'll just write that on the right and the left-hand sides. So x divided by 6 times 6 on the right, and then I have 6 times negative 5 on the left, which is, of course, also the same as negative 5 times 6, because order doesn't matter when we're multiplying. Okay, so on the right-hand side, I have x divided by 6 times 6. When I'm multiplying by 6 and dividing by 6, it's like I'm not doing anything. I undid myself there. So I can just cancel out those 6's, and I'm going to end up with an x. If you need another explanation of why that's true, is because if I were to multiply across here, I'd get x times 6 divided by 6, 6 over 6. And 6 divided by 6 is 1. So again, it's like we're doing x times 1, which is just x, because multiplying any number by 1 is itself. Okay? All right, and then on the left-hand side, I just have 6 times negative 5. What is 6 times negative 5? Well, 6 times 5 is 30, and then I have one negative sign, so this is going to be negative 30. All right, so my solution is x equals negative 30. It's standard to have the variable on the left-hand side versus the right-hand side of the equation. It doesn't make a difference. I won't care at the end of it whether you write it this way, but sometimes people will just flip it. So if negative 30 equals x, then x equals negative 30. So that's going to be my final solution. And again, I can check my work here, so I will do that off to the side. I will do that again by rewriting my equation. Negative 5 equals x divided by 6. And then I'm going to substitute in my solution, which was negative 30, in for x. So I get negative 30 divided by 6. If I did it correctly, then negative 30 divided by 6 would be equal to negative 5. And 30 divided by 6 is 5. We have one negative and one positive, so I get, again, negative 5 equals negative 5. So I know I am correct. All right, awesome. All right, now you try number 2. We have a variable on the left-hand side, but that's not going to change what we're doing. Again, you should ask yourselves what's currently happening to the variable, and then how do you undo it? Okay, give it a try. Great job. You should have gotten m is equal to negative 14. For the work that I did, the answer to my first question is my variable is currently being divided by negative 7. So I need to undo that. And how do you undo dividing by negative 7? You multiply by negative 7. Okay, so I'm going to multiply both sides by negative 7. When I do that on the left-hand side, I just get m, and on the right-hand side, I get negative 14. All right, awesome. Now let's just look at one last pair of problems that have fractions or a little bit messier numbers. I know we're not a fan of fractions generally, but you guys are going to be great. We're following the same process, so we'll just go step by step. All right, so for example 3, we have 2/3 x equals 6. Now remember that 2/3 x, that means 2/3 times x equals 6. So what's currently happening to my variable? X is currently being multiplied by 2/3. So how do you undo multiplying by 2/3? Well, there are a few ways. There's always multiple ways to think about it. But don't overthink it. How do we undo multiplying generally? What's the inverse operation of multiplication? Division. Yeah, multiplication and division are inverse operations that undo each other. So we undo multiplying by 2/3 by dividing by 2/3. Okay, so I'll go ahead and do that. Divide by 2/3, divide by 2/3. Now this looks a little bit messy because we don't love complex fractions where you have a fraction divided by a fraction. But this is all there is. We just can do a little bit of additional work if we're going to do this by hand. So on the left-hand side, I'm actually just going to leave that as is. Any number, a decimal, a fraction, any number divided by itself is equal to 1. Always. So 2/3 divided by 2/3 is equal to 1. So I'm just going to cancel that away. It goes away because it becomes 1. We multiply by x. It doesn't do anything. We just get x on the left-hand side. Simple. Okay, so on the right, we have to do 6 divided by 2/3. Now we have to go back to what we remember about dividing fractions. When you divide by a number, that's the same thing as multiplying by that number's reciprocal. Or when we flip, reciprocal means we flip the numerator and the denominator. I'm going to keep 6 and I multiply by 3/2 or 3 divided by 2. Okay? At that point now we just have fraction multiplication. That means my final solution is 9. X equals 9. So of course it's a little bit more challenging just because the calculations are challenging, but the process is the exact same. We're asking ourselves what's currently happening to the variable and how do we undo it. Okay? So looking at you try number 3, it's set up a little bit differently, but I have that x divided by 4 equals negative 3/7. All you have to do is ask yourself what's happening to the variable and how do you undo it. And then you just need to do some fraction work after that. All right, give it your best shot. All right, awesome effort. So you should have gotten x equals negative 12/7, or if you put that into a mixed number, it would be negative 1 5/7. So we're gonna ask ourselves, like always, what is currently happening to my variable, and then how do I undo it? So currently my variable x is being divided by 4, because remember a fraction bar means division. So how do you undo dividing by 4? You multiply by 4, because multiplication and division are inverse operations that undo each other. I'll just say it 7th time to make it ingrained in your head, hopefully. Always, when we're solving these equations and lots others the entire year, we'll be asking ourselves, what is happening to the variable and how do we undo it? That is the core idea of algebra, is being able to undo what's happening to the variable in order to find our solution, the value of a variable that makes the equation true. All right, awesome, great job, everyone.